The Comfort Lake Forest Lake Watershed District has been working on floodplain resiliency planning over the past few years, and the draft Floodplain Resilience Action Plan framework was last discussed by the board in July of 2025. Since then, staff has been in communication with local municipalities and other partners to review and refine the draft plan framework. We will present this at the May 14th regular board meeting. The purpose of this pre-recorded presentation is to recap the purpose of this effort and the process leading up to our current phase. This presentation will provide a refresher as to why the district embarked on this effort, the process we went through, where we're at now with the revised draft, and the next steps that we will follow after plan finalization. The image to the right summarizes very succinctly why we want to do flood resiliency planning. We live in a built environment that doesn't always respond well to the conditions that nature throws at us. The key to living in a modern built community is to use modern science and engineering to better coexist with the natural resources that surround us so we can prevent adverse impacts like flood damage. The University of Minnesota Climate Adaptation Partnership predicts spring rainfall in our state to increase by 15% statewide by mid-century and by 40% by the end of this century. In short, for Minnesotans, climate change means increasingly wetter spring seasons. The Climate Adaptation Partnership conducted a poll a few years ago and found that a majority of Minnesotans are concerned about the effects of our changing climate and think that government units, such as our watershed district, should be prepared to address it. Later in the presentation, we will look a bit closer at exactly how much more rain we are predicting for our region and what that means for our local communities. In general, for the state, the increased precipitation rates are expected to result in water pollution, flooded roads and residences, and increased insurance premiums. Adaptation is key, which is why the district began the process of preparing our Flood Resiliency Action Plan framework. Studies show that investing in proactive climate adaptation strategies saves Minnesotans money in the long run. The Minnesota Climate Adaptation Partnership found that for every dollar invested in natural climate solutions practices, Minnesota would receive $8.55 in public benefits by 2050. Additionally, the Minnesota Pollution Control Agency recently published a research study finding that investing in climate adaptation will avoid costs in the future by lessening costly climate impacts. The estimated annual costs of inaction on climate adaptation, or a reactive approach, are 8 to 15 times higher than the estimated costs for proactive adaptation strategies. Or in other words, an ounce of prevention is worth a pound of the cure. Additionally, as we've seen with many of the district's projects from the past decade, watershed management projects can provide multiple benefits. In the past, many of the district's projects primarily focused on improving water quality in priority lakes and streams. But they also provided added benefits like increased flood storage, groundwater recharge, and wildlife benefits. The inverse may be true of future projects that primarily focus on flood storage. They are predicted to provide additional benefits like water quality improvement, groundwater recharge, and wildlife habitat. Setting the stage for our watershed, we have a land use map here showing in red the most highly developed and built out areas, which are primarily located in the western part of the watershed district. Notice how these red areas are often located adjacent to water resources such as wetlands and lakes shown in blue. This close proximity between urban development and water resources means we often find homes and businesses built within areas that are naturally prone to flooding. This might not pose a problem during dry years, but as we'll see in the next few slides, precipitation is increasing, and we're going to see more and more high water issues in the coming years. The district's mission is to protect and enhance local ecosystems and natural water resources. In our 10-year watershed management plan, floodplain management is one of our primary priorities. We have a goal of adding 99 acre-feet of flood storage and to improve community preparedness and emergency response capacity by sharing modeling and mapping with local communities. With these goals in mind, the district identified the need for a floodplain vulnerability assessment to help target where added storage will bring the most benefit and to identify who to work with and how to build community preparedness. We aim to make this an inclusive process with multiple meetings with intergovernmental partners and public meetings with local residents. Note that even though it seems we're at square one with finalizing the action plan, the district's past efforts are serving the dual purpose of water quality benefits and have provided some flood storage already. So as of now, we've added 40 acre-feet of storage out of our 99 acre-foot goal. This slide illustrates the iterative process that the district has gone through in order to identify the areas of highest flood vulnerability and potential solutions. We started with a district-wide flood hazard mapping and vulnerability priority ranking. Then we took a closer look at the areas of high flood vulnerability and ran computer models to more specifically identify flood risks. Then we identified potential projects and ways to mitigate that flood risk. This is what is outlined in the Flood Resilience Action Plan framework. This doesn't mean that everything in the plan is guaranteed to occur or that the plan is set in stone. Like everything the district does, we'll work with our partners and we'll use adaptive management to incorporate new information and adjust our approach accordingly. Providing a little more detail on our process, one of our first steps was to establish what we call the design storm. That is, how much rain are we talking about when we talk about flooding conditions? Climate models are predicting heavier rainfall in our region of Minnesota in the future. The National Weather Service's current rainfall atlas, Atlas 14, does not reflect the anticipated increased rainfall for our region. The National Weather Service is working on updating its rainfall atlas, Atlas 15, to reflect our changing climate. However, Atlas 15 is not yet available. So, the district and its engineers reached out to local partners early in our planning process to see what other organizations are using for their design storm. After discussions and comparisons, we decided to use the 90% confidence interval of the current rainfall atlas, Atlas 14, which is what the city of Rochester used in its floodplain planning. This will serve as our best approximation as we await the release of Atlas 15. 2 of the wettest years on record have occurred since Atlas 14 was released. The table to the right illustrates what the change in design storms look like from existing conditions, the Atlas 14 mean value, and estimated future conditions, which is our best approximation of what future conditions will look like. For a one-year storm, or a storm we reasonably expect to see every year, we are predicting an increase of about ½ an inch of rainfall in a 24-hour period. On the more severe end, for a larger storm that we'd expect to see once every 100 years, we are predicting an increase of 2.27 inches of rain within a 24-hour period. The National Weather Service provides videos to illustrate what various rainfall rates look like. Visit the Watershed District's website or the National Weather Service's website to view these videos. The video on the left shows a 1/3 inch per hour rain event. Imagine if it rained this steadily for 24 hours. This would produce almost as much total rainfall as the future 100-year rain event. On the right, we have a video showing 1.5 inches per hour, which would be what we might expect to see during peak storm intensity. Imagine if it rained this heavily for 14 hours. It would produce the level of rainfall we're predicting for the future 100-year event. Rainfall rates vary from the start of a storm to the end, and these videos are meant to provide a frame of reference. What does increased rainfall mean for our area? First, the area within our district isn't predicted to be experiencing the deadly flash floods that we see becoming more and more common elsewhere in the country. However, flooding in our area can still pose dangers such as limiting people's ability to travel for a period of time. It is also expected that flooding in our area could cause water damage to buildings, especially basements, and lots of homes may experience standing water in their yards, where they would have previously been able to mow that grass. This is especially common for homes that are built adjacent to wetlands. Recall the land use map from earlier that showed how close residential development has occurred to water resources. Under dry conditions, wetland fringe could allow Kentucky bluegrass to grow and function as a lawn. However, wetlands are nature's way of storing water, especially after big storms, and the wetland footprint will expand to accommodate excess water. Modern watershed regulations require a wetland buffer in certain circumstances, which prevents yards from encroaching in natural wetland spaces. Finally, the intense storms that we've been seeing in recent years have resulted in the increased insurance rates for Minnesotans. Minnesota shifted from having one of the lowest insurance costs, 36th in the country in 1998, to one of the highest, 9th by 2023. As of early 2026, the average annual premium in Minnesota is roughly 38% higher than the national average. Further summarizing the district's floodplain planning process, after we decided on the design storm, we used the available GIS data to prioritize flood vulnerability on a subwatershed scale in our district. Several factors were overlaid in order to determine which areas are most vulnerable to the increased precipitation we're predicting in the future. We found that the western part of the watershed district generally has the highest flood vulnerability. Next, we proceeded with computer modeling to more precisely predict what flooding may look like in these high vulnerability areas. We were thankful to work with the City of Forest Lake and utilize the city's two-dimensional hydrologic and hydraulic model, which produced more refined results than the watershed district's one-dimensional model. This helped us quantify roadways and buildings that are potentially going to be affected by flooding. Model predictions estimate that 109 buildings and 64 roadways are likely to be affected by flooding under the future 100-year rainfall scenario. These results highlight the increasing need for proactive flood mitigation measures. Commercial areas, such as the Walmart Aldi block west of 12th Street Southwest, may experience significant parking lot flooding, while nearby residential streets are constrained by undersized pipe networks and limited upstream and downstream flood volume storage. In 2025, the district sent out mailers and workshop invitations to local residents in the high priority flood risk areas identified in the developed portions of the City of Forest Lake. The district hosted public workshops to engage with local residents and solicit feedback. A common theme identified in these workshops was concerned about backyard flooding near homes built adjacent to wetlands. Over the course of the last 3 years, the district has also hosted multiple meetings and workshops with local municipalities, state agencies, and other local partner organizations. Using the information gathered from these steps, the district engineer, EOR, developed the Draft Floodplain Resilience Action Plan framework. The plan essentially looked at the risks we had identified and came up with potential strategies to minimize flood impacts to the extent possible. This included flood volume storage expansion projects, green infrastructure, prioritization of city stormwater infrastructure maintenance and upgrades, a public outreach campaign, and incentives for small-scale residential projects. The district shared its draft Floodplain Resilience Action Plan framework, along with its adopted strategic plan, with local partners and the Technical Advisory Committee in July of last year. The City of Forest Lake provided detailed commentary on the proposed mitigation actions in January. The district engineer revised the action plan framework to address city comments, and district staff shared the redline plan framework with the city. The city is presently reviewing the redlines and will provide feedback to staff, which we will then share with the board. At that point, staff will recommend that the board review and consider accepting the action plan framework as revised. Following acceptance of the action plan framework, the district engineer will present a scope of work to the board for project modeling and concept design work, which will be funded by a grant that the district was awarded through Bowser's Water Quality and Storage Grant Program.